Hello, ladies and gentlemen. Welcome to your second lab. This one is a kinetics experiment where we're going to be looking at determining the rate orders for the iodine clock reaction. Now, just a reminder, a rate order is a coefficient, well, I'll show it to you in a minute. The experiment that the reaction we're looking at as part of our experiment is 2 iodide ions plus hydrogen peroxide plus 2 hydrogen ions going to iodine and water. Now, in this experiment, we are going to use a buffer. What the buffer is going to do is it's going to make sure that the concentration of hydrogen ions stays constant for us over the course of the reaction. So the concentration of hydrogen ions is not going to play a role in how fast this chemical reaction happens. Okay? Now, the rate law is rate is equal to rate constant K times the concentration of iodide ions to the M power times the concentration of hydrogen peroxide to the N. M and N are our rate orders, and those are going to be the first two things that we're going to be trying to determine. Okay, and then once we get M and N, we will find K, the rate constant. Now, to help us determine the rate of the chemical reaction, we are going to use a secondary reaction in the beaker. This one has thiocyanate ions reacting with the iodine molecules to create iodide ions and this S4O6 2- ion. Now, we're going to put just a very small amount of the thiocyanate ion in the vessel, and as soon as it's used up, starch as an indicator is going to react with iodine ions that are not reacted with the thiocyanate, and it's going to turn a blue-black color. It's very intense. Okay? Now, to calculate the rate of reaction, we're going to depend on rate being equal to the concentration of thiocyanate times 0.5 divided by the change in time, or the amount of time has elapsed. Because notice up in this reaction, okay, for every 2 iodides I get 1 iodine molecule, and in this reaction every 2 thiocyanates to 1 iodide. Okay? Now, we've gotten beakers and we've gotten all of our solutions, and I have made our 5 reaction beakers. Okay, so let's look at our data table. Here are our 5 reaction beakers. Now the hydrogen peroxide is highlighted in yellow because once we introduce the hydrogen peroxide, then the reaction starts. Now all of these volumes are in milliliters, and consider them going 2 places past the decimal. The computer and I were having a fight. So this should have 4 significant figures, 3, 3, 3, 3, 3 significant figures. Notice that 11 plus 3 is 4, plus 1 is 5, 6, 7, and 3 is 20. So every one of these has a volume of 20 milliliters all total. Okay? Now, all volumes are in milliliters. Okay? The concentration of the thiocyanate in the original solution is 0.0200 molar. Hydrogen peroxide is 0.0900 molar. The potassium iodide, which is our source of iodide ion, is 0.300 molar. Okay? And then we're going to make some graphs. We'll talk about the graphs in a minute. So what we're going to do now is we are going to time each one of these reactions and calculate the rate of reaction. So let's look at our beaker. Okay. I want you to look at this beaker, go grab your cell phone and have it on your stopwatch function. Okay, because you're going to time this. Okay, so I'm doing the same thing with mine. I'm going to collect the data just like you. Okay, but I'm going to keep my data compared to yours. Let me find my clock. I need my stopwatch. Okay, guys, get ready. When I say go, you're going to start timing. Okay, let me get it stirring here. Come on. Okay, get on your mark. Yeah, get set. Now, this one should only be 3 mils.
All right, I got it marked.
Okay, get on your mark, get set, go. Now, we're waiting for it to turn blue. This first one is going to take probably the most time. Okay? So, ooh. Ah! It was, yeah. That went a little faster than I was anticipating, but that's okay. So write down your time. Okay? And then we're ready to move on to the next one. Get stirred up there. All right, everybody get ready. Get on your mark, get set, go. Okay. All right, let's move on to our next one. Oh, wait a minute, that's 5, not 3. Okay, here's beaker 3. Get it started swirling there. Everything's good mixed up. All right, get on your mark, get set, go. Okay.
Next one's 5, right? 12 mils.
Yeah, next one's 5. Okay, here's beaker 4. Now guys, if you miss timing this, you can rewind the video and watch it again. Okay? Okay, get on your mark, get set, go. Okay. And we're also going to be testing your reaction time here. All right. The last one gets 7 mils. Okay, guys, get on your mark, get set, go. Ooh, okay. All right, now you have all of your data, okay? So let's talk about how we're going to process data. So let's look up here at the screen. Now, the first thing you've got to do is you've got to calculate your rate. So what you're going to do is you're going to take 1.00 times 10 to the minus 3 and divide it by your time in seconds to get your rate. So let me give you a for instance. On that first one, okay, let me grab my calculator. I've got 1 exp3 negative divided by 16 seconds, let's say. And so the first one there is going to be 6.25 times 10 to the minus 5. And then you're going to do that for each one of these. Okay? Now, you've got your rates. Then what you're going to do is you're going to fill in this chart. So to get your concentration of iodine, let me talk you through how you're going to do it. Okay? So we come up here to our filling chart. Okay, guys, scoot on over this way with me. Okay. We're going to do a dilution problem. Now, dilution means we take molarity of the initial solution, volume of the initial solution has to equal molarity final, volume final. Okay? Your molarity of your initial solution is the molarity of the iodide solution, and the iodide solution was 0.300 molar. The volume that we used in beaker 1 was 1 milliliter. Molarity final is what we're after, and the volume final is 20 milliliters. In all these dilution problems that you're doing for this experiment, the final volume is always 20 milliliters. So 0.3 times 1 divided by 20 says that my new molarity is 0.0150 molar. Okay? So on our chart, right here, you're going to point 0.015 molar. Then what you're going to do is you're going to take the log of that and put it right there. Okay? It's going to give you a negative number. Don't panic. That's what it's supposed to be. In this block, you're going to take the log of the rate from experiment 1. So you're going to take the log of that number, and it's going to go there. Okay? Then you're going to do the same thing for experiment 2. You're going to take and do a dilution and get that concentration. Take the log of it and take the log of the rate. Fill in this table. Now you're going to use data from experiment 1, experiment 2, and experiment 3. Experiment 3 does double duty. We use it in 2 different graphs. But this time you're going to be looking at the concentration of hydrogen peroxide. You do the same dilution process calculation to calculate the hydrogen peroxide in beakers 3, 4, and 5. Take the log of those and the log of the rates. Now you've already done the log of the rate of experiment 3 here, so just copy it over. Okay, so you're going to have that same number both places. And then you're going to do 2 graphs. Okay, now I'm going to put some graphs up so that you can see it. So, the first column is going to be your concentration of iodine. So my first one is minus 1.82. Okay, and then maybe it's minus 2.35. And no, these aren't the real values, except the first one, minus 3.67. Okay? And then this might be something like minus 4.2. And this one might be minus 6.7. And this one is minus 8.8. And I just made up numbers, guys, so don't expect it to be a perfect graph. You're going to highlight that, go to Insert, hit XY Scatter, just take the dots, okay? Right-click, add trend line, display equation. Now, that equation is important. Now, I'll pull this up. is what's important. Write that equation down. Okay? The slope of the line here, the number in front of x, which is your slope of your line, that's your value of m, because I was doing a mock one for the iodide ion. You do the same kind of graph with your hydrogen peroxide versus, log of hydrogen peroxide concentration versus your rate. And the slope in that one is going to be your n value. I want those two graphs attached with your lab sheet. Once you have the m and n value, use your data from experiment number 3 and plug it into the rate law. Now, what do I mean by that? Let me show you. So I have the concentration of iodine from experiment 2 and the concentration of hydrogen from experiment 3 all calculated out already. So what I'm going to come down here and do, okay, is I can type in the rate, whatever I measured the rate to be for experiment 3. Let's say I got it to be 6.7 times 10. Come on. Okay. I'll write it down here. So let's say at 6.7 times 10. Why is this doing this to me? I'll try. Well, I'm just going to write it on the board because this is giving me fits. Let's say your value of rate for experiment 3. So I'm dealing with rate equals K, concentration of iodide ion to the M, hydrogen peroxide to the N. So let's say the rate was 6.7 times 10 to the minus 5. That's going to equal K. The hydrogen iodide concentration there in experiment 3 is going to be, let's see, 3 times 0.3, 3 times 0.3 divided by 20, 0.045, and let's say this ended up being 2, and the hydrogen peroxide from experiment 3 is 0.035, 0.0135, and let's say that's to the 1. I'm not saying that's what those numbers are going to be, I'm just made up numbers, okay? You're going to determine your own M and N. And then all you do is solve for K. So at the end of this experiment, I want an M, N, and K value, and I want both of your graphs. All right, experiment 2 done.